Welcome to a webinar hosted by Keith Sinclair from Opmantek. Keith will be taking us through the latest version of NMIS. Okay, Keith, over to you. Thank you.
Good morning and good evening and good afternoon. I think that's probably covered most of our time zones. I'm going to be talking about NMIS 9 today. I'm very proud to announce that we've got a new release today, which is the 24th of June here in Australia. It'll be going up on the website later today. And so by the time anyone in the Northern Hemisphere comes online in their morning tomorrow on the 24th, it will be available for download in the Northern Hemisphere as well. And I'd like to introduce NMIS 9. NMIS 9 is our next iteration of something that I've been working on for a large part of my life. NMIS 9 brings us a next generation technology, primarily in the engine of NMIS. The feature functionality is fairly much identical to NMIS 8 at the moment, but we needed to enhance the core of NMIS to do the things that our customers wanted to do. So the teams put together this nice graphic to sort of represent how NMIS works. And we're going to go through these components today, in some level of detail. But NMIS 9 is available as of today. So why NMIS? Let's look. It's not just about NMIS 9. It's about NMIS as well. If you're not already using NMIS, you might not know some of the higher level or values that it brings, benefits that it brings to your organization. And the core system is a sophisticated business rules engine. So it allows you to have business rules. So you don't just classify things based on arbitrary technical details. You classify things on their impact to the business. And that represents itself several times through the product, but it's a core tenet of how NMIS has been built. It works out of the box. We have a lot of support for a lot of devices out of the box, and you can add new devices using the modeling system. And there's also plugins and plugin system, service monitoring, fully compatible with Nagios plugins. You can take a Nagios plugin and have it used by NMIS. So it's very, very extensible, and out of the box things work and very easy to get additional things supported. A visible operational impact, really important to me, is the ability to see what's changing in the environment, and it's got to be visible. So we have that represented right through the GUI for stacking. So when you have a high level, you have a small router go down somewhere or other, it'll be reflected through to the dashboard that there's an impact somewhere. And that's a very, very critical thing, because sometimes that little router can be causing problems. And then of course, if big routers, big switches, big servers go down, their impact is more visible. Automated health live baselining. So this is, again, a core feature of NMIS. It's been there for 20 years. And that is all about knowing how the network, how the environment is behaving now compared to before. So we take a baseline of how the performance is right now. We compare it to the previous 8 hours. So we take the last 8 hours, compare it to the previous 8 hours, and it's there in the GUI, and it helps us to see if the network or the environment is improving or getting, something's going worse, getting worse, or getting loaded, more heavily loaded. Massively scalable. NMIS has kept evolving over time and really does scale to a large node count per server. And then, we can run multiple servers, and that's a really core functionality that lots of our customers rely on. But you can get a huge number of nodes per server, and that really helps you to make it fit in large environments. And everything's customizable in the escalations. So you can have NMIS just tell you what's going on, and you can have it tell you at different things at different times of the day. You can have it send emails to the team, and then if no one's responded to the alert, it will then start sending emails to other people. You can have it send paging messages, or just about any sort of thing that you want to do through the notification system. So there's some core things about why NMIS is valuable, and we continue those on with NMIS 9. And especially, I think the key thing probably in NMIS 9 is that scalability is increasing markedly. So a little bit of history about NMIS, a bit of a timeline. So I was putting this together and sort of shaking my head for a part of it because it's been a large part of my life for a long time. But back in '99, I was building networks. I'd become a CCIE in '97, and I was building networks for people, and I was asked, how do I get visibility? Now you've given me this network, how do I know if it's working or not? And so I started looking into network monitoring and management even before I was a CCIE, but you know, it became really repeated questions when I was building networks. So I started looking at commercial tools, and I started looking at open source tools, and found that there just wasn't a good balanced solution that provided, you know, a bit of fault and performance and a bit of event management, and, you know, just gave me some, what I would call Pareto's principle of network monitoring, that the 20% of the functionality, that 20% of the features that delivers 80% of your requirements. So that's what NMIS was created to do, just deliver that core functionality of performance and fault management, and with some event management, escalation, and so forth. So it was back in '99. I released it to open source, and I was sort of a bit stunned at how quickly it took off. I knew that it was a problem people were having, but I didn't know that many people were having it. So there was quite a lot of activity. You know, it was sort of released very quietly to just a website, and then 2000, I put it up on the RRD tool page, and the Yahoo group was launched, and then just a lot more activity. And I think SourceForge, looking back at the history, the SourceForge page went up on 2001. SourceForge was a precursor to GitHub, for those who don't know who SourceForge is. Just about all open source projects were on SourceForge. And then we rapidly released, or at the time, NMIS 1 and NMIS 2. And then Eric Greenwood got involved fairly early on. Probably it was in 2001. And then in 2002, I'd actually moved to the US, and NMIS 3 was released, and Eric sort of took over as the project lead. I was still involved, but just not so much in the front foot. I was still contributing and still doing things and still involved, but I just didn't have the time because I had a baby girl and was very busy with my full-time work. So NMIS 4 was released in roughly 2005. NMIS 4 was considered stable and feature complete in 2007, and that's a really important milestone. There's a thing I say to people, that version 4 of a product is usually when anytime you've got a major version, you get to major version 4, usually you need to go to the next level, you need to do a re-engineering of some description. And that's what NMIS 5 was all about. So the development on NMIS 5 started in 2008 and went through to about 2010. And then around about then, Opmantek was formed. So Danny Marr decided to, contacted me, and long story short, Opmantek was formed to commercialize NMIS. So we took NMIS 5, called it NMIS 8, because there had been a bit of a time between NMIS 4 being released, and we released NMIS 8 in April 2011. And then later that year, we then released 8.1, 8.2, and 8.3 were released in great succession. And funnily enough, that was our 8.3 was our fourth major release, and version 8 was pretty solid by then. And we, 2012, we started developing the Opmantek commercial modules. So that's what our customers asked for. They said, NMIS is great, we want all these other features. So we started adding products like OP Reports, OP Maps, OPHA, OP SLA, OP Flow. And then 2013 to 2019, we released NMIS 8.4, 8.5, 8.6. NMIS 8.6 has been very, very stable. 8.868G was actually 2018. So that was released, and that's been very, very stable. And we've now just revved that just last month into 8.7. So we're considering 8.7 long-term support, and that'll be with us for a long time, and we'll be absolutely maintaining version 8. And then it brings us to today, 24th of June. We're releasing NMIS 9 today. So a bit of history, why we're where we're at, but and an important milestone through all of these versions. So what's changed in NMIS 9 and why does it matter? So we've enhanced the NMIS engine. So we kept the best bits, we've improved performance. That was one of our big goals. And we've done that several ways, and we'll go into some details in a second. MongoDB replaces the NMIS 8 file system database, and the master server has more data available. And that's a really key functionality that our customers were after. They really wanted to see more data on the master server so they could do more with their large environments. And then we're going to be doing another session in a month's time, some more details about the commercial modules, but there's just a lot more functionality there that you can do with multi-master and multi-server features. And we'll be covering the details of that in a session next month, later this month. No, next month will be July. So enhancements of the engine. So keep the best bits, improve the performance. So we kept all those best bits. So the system remains configuration and model based. That's a core tenet of NMIS and our commercial products, is that things are configuration based. It is really, really important that that's possible, because it's how you can automate the software. If you don't have a configuration based system or model based system, it's very difficult to automate things to happen. So we've kept all of that. And in fact, the models are 100% compatible. We'll probably be enhancing the modeling system over time, but right now, NMIS 8 models and NMIS 9 models are the same. We have a new scheduling system that's a polling daemon, so it ensures that the resources are better utilized. We'll go into a little bit more detail about our worker pool shortly. We have improved out-of-the-box functionality, and it's easier to customize. So we've really simplified. We went through a lot of the sort of defaults and things in NMIS, and we tweaked. The dev team spent a lot of time discussing a lot of details that would probably bore most people, but we went through a lot of things and just tweaked some of the defaults and how things were configured, and that's there through the system now. And then really, that also goes over to the next point, better long-term maintainability. So you don't have to, we have this concept of default and custom things. So we're going to go into some details about that in a minute, but you don't have to, if you don't modify a configuration, you're just using the default, which just means that you have less to think about. So when we're doing patching and we're doing new versions, we support backwards compatibility. That's a architectural driver for Opmantek development, is backwards compatibility. So this helps us to do backwards compatibility. We can ensure, and help maintain systems longer term for you guys. More precise logging and better reporting of statuses, and that's a really important functionality. So then we move on to MongoDB replaces the NMIS 8 file system database. I've been amazed at how well the file system database has worked in NMIS 8. It still works really, really well. We find it taps out at really large implementations. Although it still works, we know that was a bottleneck for us in several areas. So we needed to replace it with the database. There's actually been several times the databases have been used in NMIS to improve its performance, and they never made it through to the open source code. Probably don't know why, but it just didn't happen from the project point of view. Now we have an MongoDB under there. I think there are limitations with SQL databases, which is more of a theological discussion, but we went with big data. So we went with a big data approach for all node, event, and status data. It's all in the database. It's all available. We're going to talk about that schema in a little bit more detail shortly. We have a holistic view of the data that now reflects all of the data, and it's easy to look for data across many nodes. You'll get the full benefits of that using OP charts. There's improved search and ability to quickly search across all the inventory data. And again, you'll get the full benefits with OP charts. There's reduced disk activity, and this was ultimately our primary goal with using MongoDB. MongoDB is a fantastic database. We'll go into a little bit of detail about MongoDB in just a second. But one of its key functionalities or features is that it's an in-memory database. So things that are stored in it that are in the memory, that are in the index, are in memory. And that's the goal of when you build a Mongo database, is that you want those indexes to be in memory. And then, of course, if it needs to, it'll hit the disk to get data. But generally speaking, the data you're accessing all the time is in memory. Makes it very, very fast. So if we're very careful how we curate our database schema and those structures, And that means that we do our best to keep, have enough memory on the system. That's important. And then you have, when you hit and you're doing queries and you're searching for things, you're not hitting the disk and you're not loading files. And that's where we get a lot of performance improvement. We've actually seen also that while MongoDB uses more memory, each NMIS thread uses less memory. So that combination evens out and the performance goes up. And that's been, so, right now we're seeing from the servers that have been deployed, we're seeing the same amount of memory on a Polar, able to run slightly more nodes, basically more nodes than you can today with without MongoDB, because you have to have more data in NMIS 8, more data loaded in memory for every thread that's going to poll a node. So why MongoDB? I asked MongoDB this, or actually asked the internet, and so there's a page there. You can actually just literally Google why MongoDB and you'll find this page, and I've put the source there at the bottom. But there's a quick summary about MongoDB. It's a document data model. It's very, very powerful. It resonated with me instantly when I started looking at database alternatives at the time. This was 8 years ago. I've been using document style development for a really long time. For those who don't know, I did a lot of work in XML back in the noughties, a huge amount of work in XML. And really JSON, has delivered what XML failed to deliver. Excuse my tongue in cheek. But XML is incredibly JSON is incredibly flexible. And at the end of the day, MongoDB is a JSON database. It's very, very powerful, very fast, lots of great features, and very, very easy to understand and use. Query engines are great, lots of great little GUIs and tools for it, very powerful. So why MongoDB? That's why we chose, these are the reasons we chose MongoDB, and a lot more. It scales, it does all sorts of cool features that we're not even needing to leverage at the moment. So the master server has more data. So we have better support for centralized data storage. We have features available on the master. So all of those Polar features that people loved in our products are available on the master now. Things like top-end topology maps, interface, inventory search. The inventory search is really cool. The most recent performance data is also available on the master, as well as on the Polar. So there's a really subtle thing, and we'll go through that in a bit more detail in the schema. But yeah, there's the most recent performance data is available on the master as well, and seamless access to the detailed performance data. So when you're using a master server with OPHA and you want to see that graph, we don't put all the detailed performance graph data onto the master. You're looking at the GUI, you click on a graph, that graph is seamlessly the graph data is seamlessly using an API called coming from the Polar. So that works really beautifully, and it simplifies your portal complex, if you like, your DMZ. You don't have to have holes open through firewalls to the Polars. The user talks directly to the master, or the port, what we call the portal master. That's where the user talks, and then the data is directly taken from that master server. There's a socket connection back over to the Polar, grabs the graph data, puts that through, all transparently, works beautifully. But that's a big goal for us with NMIS 9 as an engine, was to help deliver more data on the master for our very large customers who have, and just for those who don't know, we have one of our customers in Mexico is managing over 100,000 nodes with NMIS on many servers, obviously. And that's, these are the sorts of features that they ask us for. So what's the same and what has changed? I just want to summarize this a little bit. What's the same? The GUI is the same. In NMIS 9, the GUI is the same as NMIS 8. We actually decided that was a good idea for the short term. So as we go forward with NMIS 9, we'll probably start tweaking the GUI and making changes and improvements. But right now, the GUI is the same. So for those people who have operations teams relying on the NMIS 8 GUI, no fundamental change in how it's working. There are a few little minor changes, but in all the major workflows using NMIS 8, it does not change. NMIS 9 is the same. And lots of things are just happening transparently under the covers. All the features that you love are still there. The thresholding, escalations, plugins, all those features are still there, still exist. Configuration is the same. Services, escalations, polling, policy, all of that, all is exactly the same. None of that's changed. RRDs are the same. We will be tweaking and making some enhancements over time to the RRD schema. Now that we've given you compatibility, there are some things that we need to do to improve and go forward to maybe get better performance out of NMIS 9, but we'll make those optional. So we'll release a set of schemas that will be, let's call them optimized database. This will be a set of models, I should say, that'll be optimized in the future. And that'll just reduce the polling and do a few things to improve. For those large scale deployments, we need to save milliseconds, right? You know, and a millisecond off 1,000 nodes is 1,000 milliseconds. And those are the sorts of things that we do when we look at scaling now. What has changed, I tried to think of all the things that had changed, and there's probably impacting you directly. The really two big things that have changed, pardon me, is there's no nodes.nmis anymore. It's gone. But the node admin tool is still there. That node admin tool was added a long time ago to NMIS 8, and that's how, you know, we recommend people sort of administer the nodes in NMIS all through the GUI. And the nodes.nmis is still there. It still exists. It's in the database now. And it was really important. The development team really pushed me on this because I wanted to keep the file, but so that we could have referential integrity, so that we could do a lot of the cool things, we need that nodes.nmis to be in the database. So it's in the database. It's still there, and you can use the node admin to add and remove and delete. We call it CRUD, create, read, update, delete nodes. So that's all those functions are available through the GUI, through the internal NMIS APIs, and through the node admin tool. And the other thing that's gone that people probably have been using is the node name node files. So in the var directory, there was these node name node files with all the data about a node. That's all now in the database. So you can actually still get it through the node admin tool. You can do an export of a node and basically recreate that data. And so you can still sort of query it, but it'll just be, if you're doing any integrations, which never a good idea to do file level integrations, but if you are, you can still sort of recreate that capability by, you know, a few CLI or through the NMIS 9 API, the Perl API for NMIS 9, you could absolutely go and get some of that data out. And the Perl API is very, very powerful and you know, available to you to recreate things that you might have been doing this. But that's what's changed. It's the fundamental things that have changed to people using NMIS. So I'm going to pause for a second. Have we had any questions come up at all, Adam? I'm not seeing any.
No questions yet, Keith.
Okay, we'll roll on. So if you do have questions, please pop them in the chat. More than happy to pause and answer questions as we go. We're well and truly on track for time. So what are the important concepts for NMIS 9? The most important one is the job processing, and we'll go into the details of this, but there's no more cron. So cron is gone. We have an NMIS 9 daemon, something I've wanted to do for a really long time, and again, been amazed at how well cron has helped us over the years and supported us. Configuration of models, how they work is a really fundamental concept, and the NMIS 9 data structures. So we'll dive into a little bit of detail into each of these. So how does NMIS 9 job processing work? So we have NMIS 9 has a daemon, and it starts and it spawns the minions which live in the worker pool. So this is a software pattern, if you like, that's very popular and very effective, and it's been around. It's not a new pattern; it's a very effective pattern. But basically, there's a supervisor thread or daemon which manages and maintains this worker pool, and then as work is required, is put into a queue, and the worker pool looks for work to do in that queue, and then it performs the work. It's very scalable. It's very straightforward. And you can see that it's all visible through the operating system. Very easy to see this all happening. And how many workers you have determines how much work can be done in parallel. Sounds kind of obvious, but you know, if you need to have more nodes, you're going to need more workers. And it's that simple. So if you're going to have less nodes, you can have less workers. More workers need more memory. Less workers need less memory. Simple things. Everything is done through the worker pool. I think there might be one or two little cron jobs left that it might be some reporting jobs, but basically almost everything is done through the worker pool. So the NMIS9 daemon starts. In its core, it has a scheduler. So it's running all the time, figuring out what needs to be done. As it sees things that needs to be done, it creates jobs and they're added to the NMIS9 queue. So we have our scheduler sitting here, pushing things into the queue, and then the queue is running and the worker pool looks for things in the queue and executes those things. Items in the queue have a priority and have lots of properties. Now that we have a queuing system, there's lots of cool properties that we can do with queuing systems. And now the workers look for jobs to do in the queue and they start executing those jobs. And then once they're done, they're ticked off and that job is done. It's a standalone job. It basically just tells the system, the rest of the workers and the master that the job is complete. And it's a standalone job. And that's how the system's been designed. But what happens is a collect process, for example, has a higher priority than an update process. So if the server's busy, lots of things are getting added to that schedule. You might find some jobs aren't getting done, and that you'll see that the queue can grow. That means that you're running out of workers. You don't have enough workers for the work going on. But everything is a worker, is a job, right? So the escalation process, there's an fping, there's a dedicated fping daemon or worker that just takes care of the fping process is automatically managed by the NMIS9 daemon, but everything else is just handled by that worker pool. You now use the NMIS9 CLI, and that's a CLI tool that you now have to interact with the daemon. So you can do all sorts of cool things with that CLI. Won't be going into any details of the CLI today, although if people have got questions about that, I'm open to diving into terminal sessions and showing people whatever they'd like to see if we've got time. But the NMIS9 CLI is really, really cool. Lots of great documentation about that on the wiki page. And it's how you interact with getting things done. So really fundamental change is when you want to run a collect on a node from the CLI, like you're troubleshooting something and you want to run a collect, you ask the CLI to ask the scheduler to add that job. So you go to the CLI, you run that command, it gets added to the scheduler or into the queue basically, but you're asking the scheduler to add this job for you. The scheduler adds the job to the queue, and then at some point very, very soon, usually straight away, that job will be executed and run. And if you want it debugged, you would ask it to be debugged, and then that debugger is sent to a file, and then you grab the file. Very, very straightforward, probably twisting some people's brains a little bit because it's a little bit different, but this is what we needed to do to get that next level scalability and performance. So the NMIS9 are monitoring that queue, looking for what to do, and everything they do is just driven out of that queue, and that's what happens. So this gives us a non-blocking architecture. So we have this non-blocking scalable architecture. More workers means more work to do, and on a single server, you could be running hundreds and hundreds of workers, and this sort of simulates the way NMIS8's been working for some time. That you could end up with 100 threads running. And that's, you start a poll cycle, there's now 100 parallel threads running. This is the worker pool, you'll have 100 workers there doing the same sort of work. So that's NMIS9 job processing. Very, very powerful. It's some conceptual stuff that you probably need to get your head around, but it's really quite straightforward. Ultimately, this is how Apache works. You sort of think about it like that. You have a set of Apache processes that are processing web requests. You have a set of workers, HTTP daemons that are sitting there in memory ready to receive requests. This is how a lot of software you're very familiar with works today. So next big concept is NMIS9 configuration and models. So what changes here? So we now have this sort of base concept. We have by default you'd be in user local NMIS9. So you have this directory called conf default, and then you have a conf directory. So let's say you had not modified the services.nmis, where you would modify services monitoring configuration for servers or for other devices. Let's say you had not modified that. It would only live as the one that we've shipped with the source in conf default. No need to modify it. If you go to the GUI then and edit services.nmis, immediately NMIS will copy that file into conf, and your edits will now be in that conf directory. So very, very simple. If you've never modified a configuration, it'll be in the conf default. If you've modified a configuration, or you're going to go to the CLI and do this for the CLI, you should copy that services.nms from conf default into conf, make your edits, and now we know and you know that you've modified the configuration, right? So really, really important concept, really important, very simple idea that conf default is the default configuration. If you've modified something, you see it in that conf directory. So it's probably just, if you're troubleshooting, it's probably a little bit, you know, if you're trying to understand how something works, and we'll show you, we'll talk about something in a bit more detail in a second, but, you know, we have this hierarchy that I'm going to go through in just a second, but, you know, that's really that's the first concept that's really straightforward. So typically speaking, in everybody's conf directory, there'll be a config.nmis, and there might be, you know, one other config file. You might not have much that you've needed to modify. On more complex installations with customers who use more features of NMIS 9, they'll have a lot more things in their conf directory. But all those default configurations that we ship, so there's a lot of things like enterprises.nmis that really are just maintained by Opmantek now. I mean, customers contribute to them as well, but generally speaking, you know, we're gonna make sure that those get updated and pushed out all the time. So that's your enterprises.nmis. There's a lot of things there that you don't need to worry about. They're all just going to live in conf default forever. And as you get a new patch for NMIS 9 or a new update, it's going to just update those files seamlessly. You're not going to need to worry about it. Now we've added, to make it a bit more flexible for people doing automation especially, we've added the conf.d directory. So underneath the conf directory, there's a conf.d. So you could actually just do config fragments. So you could have in that directory, the classic would be an auth.nmis. So instead of having config.nmis, you could now have the config nmis config file broken into several segments, and you would have, really great example, your auth.nmis, which is just your auth configuration. Now we'll go into the configuration hierarchy. So what nmis will do, it'll load all the config in conf default, then it will look in the conf directory, then it will look in the conf.d. So there's a hierarchy, and those configs are overwritten by the last thing loaded, right? So this is really great way to let you change your configuration and support automation and support systems using, you know, if you're using Puppet and Chef or things like that. What's the other popular one? Ansible. You know, you might be using those systems to manage your configurations. You know, this simplifies that for you, that you don't have to really think about it. You can just be dropping those config fragments in and just in that conf directory. So that's your configuration hierarchy. We've done almost the same thing for models. Again, there's a models default. Those are all maintained by the NMIS 9 community. As new models are created, sent to us, or as Opmantek are creating models for customers, they go into the models default. So basically, all the models that you'll see in NMIS 8 are across there in NMIS 9. I think one of the team, Nick, I think did a recent merge between the models. We'll do another one soon, but you could literally go and take the models out of NMIS 8, drop them into NMIS 9. It's no problem, but they're all in models default, and they're all going to be maintained, and we're going to keep pushing changes in that models default. If you've modified a model, you should copy it out of models default. So let's say you've got some new modeling that you want to do, brand new device you want to support, you can just drop that in models custom, and then that's your models that you customized. So when we release a new version, we just go and blindly update that models default. If you've modified the Cisco router model, for example, it won't matter. We won't touch it. It's in models custom. We're not going to touch it. It's going to stay there, and you've got your customized things. You can later on, when you're ready, you can do a version check or a difference check between the default and your customized model, see what's changed, and you decide when you merge in those changes. And this works, so that how that works is that NMIS 9 goes to load the models. It looks, as it goes to load a model, it looks in the models default, it loads. If it finds a model file in models default and it finds the file in models custom, it only loads the one in models custom. And it will then look in models custom for any files and load those as well. So anything in models custom overrides what was in models default. So really, really powerful, really going to help maintainability of NMIS 9. We've seen this as one of our things that people have had trouble with, and maybe especially where we wanted to improve the product and help. We know we have to change something in the product. This is going to help us to help you longer term as well. So that's a really core concept, very, very important. And it's really happy with how it works.
Hey, Keith, there's a related question just come in the chat.
Yep, that's from Drickus. So Drickus is asking us, I don't know who can see this chat, so I'm just going to read this out. So would custom models from other customers' community be added as default over time into models default if they're considered to be non-customer specific but vendor general model updates? Absolutely, Drickus. That's what we've been doing since NMIS 8 added modeling. So what we do at Opmantek is you have several options for doing modeling. Many people do it themselves, and that's no problem. And if they send us the models, we just check them out and we add them into the models, into the source. So this has been happening forever. So models default conceptually is what we call models install today in NMIS 8. There's a models install folder. We go and take models from the community and we add them in, and they get merged in. And that's how we've got a lot of device support has been from the community. Customers also pay Opmantek services to create models for them, and then models that Opmantek create, we put into the models install directory, and they're available for everyone, and that's the same that'll happen for the models default. So absolutely, that's how we get great device support, and how NMIS has always had great device support is from community contributions. What we do get, just so everyone's aware, we sometimes get conflicting things. So one customer asks for a pink monkey, another customer asks for a blue monkey. So what we try to do is find the middle ground and provide monkeys with then color options. And that's always, the challenge. So with that, you might sometimes see a set of models in there with a different name. So as they've been contributed, if they conflict with existing stuff, but it's what that customer wanted, that's okay. We add them in, but we might call it Cisco router dash, custom, or Cisco router dash something else as an alternate Cisco router model, for example. Cool. I'll roll on to the next data schema concept, wanting to leave more time for questions. So NMIS 9 data structures, this is the top level data structures. These are the core. So in MongoDB, you have a database. So the database name is NMIS NG. Now, you should never ever call anything NG because that's next generation. And as soon as you've released it, it's not the next generation. But we're just going to go with this for now. And it's the NMIS NG database. And then under NMIS, under MongoDB, you then have collections. So and a collection is analogous to a table. It's a similar thing, but a collection, it's not a table because a table is two-dimensional, and MongoDB supports rich data structures, 3, 4, 5, 6 dimensional data structures, right? So you basically, the top level collections that we have are events, inventory, latest data, nodes, op status, queue, and status. There's a quick description. They're pretty much self-explanatory. The one that's probably is important to describe, or the differentiator, is the inventory data is static. So but it's collected from the device, right? That's the really important thing. So when I do an update and I run an update on a node, that creates inventory records. So when I collect CDP neighbors, when I collect the interface list, when I collect that information about what is the device, what makes up the device, that's inventory. That's what we would call static or rarely changing. Static's not the right term, but rarely changing information, right? So relatively static information. Latest data is dynamic data that NMIS collects every xpol, every seconds, x seconds, minutes, right? So latest data. So if I'm polling a node and I collect that latest data, I would collect the interface, I'd collect the input output stats and packet stats. That would be in latest data. We've written away the data to RRD, and we keep a copy in NMIS in the MongoDB so that it's available there for different things that you might want to do. So that means now that we have recent performance data in memory in the database. The nodes collection is node configurations. If you modify a node, you change something manually, you edit a node property, that's going to be in the nodes collection. Right, and that's really, really important. I'll come back to catch-all in a minute. Op status is things that are going on, and we'll keep enhancing that operational status, but things that are going on jobs that have been completed are all going to be recorded in the op status, problems that the system's having. We're still logging things to files, but we want this op status so that we can use it for querying, looking in the database and doing things in the software so that we can do things in a bit more programmatic way. So that's what op status is the operational status. The queue is obviously self-explanatory, and you can flush the queue, you can manipulate the queue, and the CLI tools there for that. Sometimes in support, and we've done a lot of work to optimize the queue. Has really been heavily optimized. And I should probably add, and I don't know if this was clear, NMIS 9 is not beta. NMIS 9 is fully released general availability today. It's been in beta for the last 2 years. We've been making it available to customers. We've been working with Brennan IT for a while, and they're in production and have been in production with it for some time. And it's production ready. And that queue system was a system that, we've done some enhancements to and improved in the last 12 months especially. So the queuing system is working really, really well. And you shouldn't have to do much with it, but if you had a really busy system, that queue will be something that you could keep an eye on. So events and status are the two fundamental, really important data structures that are there. The events is the event database. So that's the current state of all things being managed. And we had that event database. It was a file system database before. That's now in MongoDB. And the status was one of the sections as part of the node file. It's now a status, what we call a status. As the status of things changes, we update the status. And that's how we derive, degraded or not for things. So that's the high level structures. Let's dive into a little bit of a schema. So there's the relationship. I created this entity relationship diagram just at a high level. Sorry that I didn't have the little many-to-many sort of indicators here on the lines. But you have in the core of this, you have nodes. They're the obvious thing. Nodes have a UUID. They have a name and a UUID. Everything in NMIS 9 is about that UUID. So if you're managing inventory, and we did introduce UUIDs in NMIS 8, it was really important in NMIS 8, but a node was indexed by its name in NMIS 8. In NMIS 9, a node is indexed by its UUID. But you still need to be careful about names. You can't have duplicate names. More on that if people understand how that works. So basically, inventory, you'll see that every other thing has a node UUID. So that node UUID refers back to the UUID of the node. Everything has a cluster ID. A cluster ID is the ID of the server, that is the poller that you're on. So whenever the poller is doing anything, it's writing the cluster ID to all of these records. And this is what we need for multi-server systems. So when you're on the master, you know that the data came from which poller it came from, which cluster, which item in the cluster, which server in the cluster did it come from. So the poller, whenever it writes records, always includes its cluster ID, which is its personal ID, which is configured in NMIS in the configuration. It writes its cluster ID into the configuration. And then when that data is copied up to the master knows where it comes from and can deal with that data, because we need to know, right? We need to know on the master where the data came from. So then the other next really important concept is inventory ID. So where we've got latest data, for example, and I forgot to link I just got it to the wrong line there, sorry. So that inventory ID should be linked down here to this inventory ID, not to the node UUID. So latest data and status data all link back to the inventory ID and the node ID. So those concepts are related to something. So for example, interface property, latest data for interface properties would be the latest packet stats. They would relate to a node and to an interface, which would make it, related to an inventory item and a node item. So that's the high level entity relationship diagram. We'll work at fleshing these out a bit more detail. And we can have a look, if we've got time, we can have a quick look at the schema in one of the tools. That's your entity relationship diagram at a high level. And then inside inventory, this is probably the one that most people are interested in. The node one is fairly self-explanatory. The nodes one actually looks a lot like the nodes.nmis file, like the documents inside. The inventory one we'll just sort of break that down a little bit more. So every record has an ID. That's a concept in MongoDB. That's just automatically assigned by the system. So then every record, obviously, as we just discussed, has a node UID. And then we have expire at. So we use this feature of MongoDB for expiring data. You don't have to delete data. You just expire it, and then MongoDB deletes it later on. And then we have this concept called history, which you mark something as historic, which means it's old, and at some point in the future, it'll just be deleted. And then you have what's called a concept name. So an inventory record will have a concept. So the concept would be interface, CDP, BGP peer, etc. And then you have the data that's actually for that concept. Then you have a path, which tells you where it relates to. That's in the path in the inventory, if you like. So it relates to this node and this interface. You know, there's a path logical structure that this inventory item fits into. And then the storage that tells it where the RRDs that might be related to this item are, you know, stored. There's more properties than that. They are the really crucial properties. Now there's a special inventory item called catch-all. So when you're working with nodes and there's things that you want to know, you'll remember that there's in the nodes file, there's this nodes.nmis. So node name -node.json. There's lots of cool data in that people want to manipulate and use. And that's now in that catch-all data. So that system data was called in NMIS 8. That's now what we would call the inventory catch-all data. And that's all that cool SNMP data that you would ask the node, sys description, sys location, you know, in serial numbers, all that sort of node specific stuff all ends up in that catch-all data. So it's called an inventory record, and it's called catch-all. And we decided to do it that way. We could have had another database table or collection called node stuff, but we just decided, you know, that let's use this sort of catch-all concept. So that's a really important concept to understand, that there's this thing called catch-all, and often it's catch-all. It's going to catch all the things that you haven't thought of, right? So that's kind of why we use that. And we're pretty happy with how that is working in the system. And that brings us through to questions. Now, we've got some time left, which is good. That actually took a bit longer than I thought, so sorry about that. Is there any questions? If there's no questions, I might just bore people to death with the look at the schema. I can show people an NMIS 9 GUI, but it just looks like NMIS 8. Is there something, any requests out there? Silence. Oh, Drickus. Go ahead, Drickus. I don't know what I do now.
Oh, I'll let you talk, mate. Okay, you're on.
There you go. Hi, can you guys hear me?
Yeah.
Yes.
Cool, man. Thanks for everything so far. So NMIS 9, will that stay pretty much free as NMIS 8 was?
Absolutely. NMIS 9 is absolutely fully open source. NMIS 9 is open source. It's on GitHub right now, and we'll be updating GitHub today with the latest 9.1 release that's going out today.
Okay. And how do you position 8.7 versus 9? Would there be a reason why you guys would recommend somebody to go rather stay on 8.7, or just say, well, if you're new to NMIS, rather go NMIS 9?
That's an excellent question, Drickus, and I have the answer. So if you were new to NMIS and you were expecting a larger environment, so if you're an MSP and you're new to NMIS, I'd be fully recommending NMIS 9. It's going to take you where you want to go in the future. If you were using NMIS 8 for the last little while and you didn't have huge node counts and you didn't have these scalability problems, then NMIS 8's fine. It's working really, really well. It scales. It actually scales to thousands and thousands of nodes per server. So but if you only had, especially if you probably only have one server, NMIS 8 is it's fit for purpose. It's very, very, very functional, and it works. So if you're new and you're coming into NMIS now, you would go with NMIS 9. If you've got NMIS 8 and you've been using it for a while, you should be thinking about, and you want to do scalability, you want to do multi-server, you should be thinking about migrating to NMIS 9. NMIS 8.7 is going to be long-term support. We'll be supporting that. I mean, I don't want to think about, I'm not going to mention how long we supported NMIS 4 for. But you know, we will support NMIS 8 for a long time, but we just won't be putting new features into it. That's probably the biggest thing. As we go forward, we're going to be doing things in NMIS and improving it, and those things are going to go into NMIS 9. So, you know, right now it's probably not a big gap. Maybe in a year or two's time, you'll see a larger gap between NMIS 8 and NMIS 9.
Cool. Thanks so much.
But yeah, open source, absolutely. Open source core. That's an absolute belief of Opmantek. We are open source at the core. This business model has evolved, and it's actually, I think our customers love it. And that is that you've got this full-featured open source core, and you know, an NMIS and open audit. You can do everything you want to do. And if you want those extra bells and whistles, you want those extra cool things that we do in our commercial products, they're available to you. Cool. Any other questions? Excellent. What I'll do, just to finish up, I'll just have we'll have a quick look at, I'll just show you, if you're doing NMIS 9, this is probably something that you want to see, is just having a look at that database. You probably want to install a tool like Robo3T. There's several other tools. Robo3T is a pretty good one. I liked it because 3T is a cycling brand. That's why I think I downloaded it initially. But it is an excellent tool. We're going to connect to, or Polar 9 will do. It's probably a very busy server. It's one of our test servers running about 500 nodes in the lab. Oh, here's me looking for the screen. It's just here. Okay. So we'll have a look in that NMIS-NG. We go to collections, and here you can see those database structures that we talked about. We'll go into the nodes one, because that's probably the one that everyone is keen to see. Now you have a list of objects, and so we just expand one of those, and you'll see here that we start off, this is for a router called RR1. So there's its name, so you can see that at the top level. There's its UUID. That's the UUID that's going to be used right across the system. So here's the activated. Is this activated in NMIS or not? And then down here we have the other properties. So here's the addresses of the node, which is actually empty. And then we have overrides, which is not being configured. We'll go look at what might happen. And there's all those classic NMIS nodes.nmis 8 things that are right there in the configuration. So, you know, the proof, all of those properties that you would manually enter or be using an API to enter from your CMDB or something, you know, they're all there in that nodes file. So let's go and have a look at the catch-all data. We'll go to inventory, and then we just go concept is catch-all, and we run that query. And that now gives us the records that are really useful that people like to see. So this is a catch-all data for RBogon 33. And yes, that's one of our lab routers. And if we look in data, you'll just see all of that classic data there that you want to have access to. And we've actually copied across some of the data from the nodes record, but this is the live data that NMIS is using. So where is it? So there's all of the sys object name, the sys contact, sys description. As we've queried the device and we've got SNMP data, it's being updated in here. So this is the live dynamic data about the node that's being collected and maintained. All those, last time I polled it, all of these sorts of properties that are interesting to us, are all here in that catch-all data. And when you use the NMIS 9 API in Perl, you know, you just don't have to worry about this. You just ask that NMIS 9 API about the node, and it's getting it from the database for you. So you don't have to really think about this. It's just, it's good. It's really powerful to have the data in MongoDB. Where you used to go to the CLI to do things, you're now going to probably pull up a tool like this to see some data. And you can obviously run queries and pull data out. So if you wanted to be using Python to extract data from NMIS, that would be really easy to do now because the data is all in a MongoDB. Cool. If there's no other questions, we'll call the webinar to a close. Please feel free to reach out. My email address is keiths@opmantek.com. If you've got any questions, you can also send an email to support for technical questions or contact for any commercial questions. So contact@opmantek.com.
Thank you very much, Keith, and thank you very much to everybody for attending today. I wish you the best and look forward to seeing you downloading and trying NMIS 9.